So problem 67 is a compounding problem. And how it will work is similarly how we looked at these exponential functions earlier. Y equals a times b to the x, where a is your initial value and b is your rate of growth. Now this is a little bit different because it says given the annual rates below, solve for the time it takes for the amount to double under exponential growth. Bring your answers to the nearest year. So you see in this example, our interest rate is 1.02, which is the same as this. And that's our B, or our rate of growth. Our initial value doesn't really matter because all we care about is how long it takes our money to double. So we're taking A and multiplying it by 2, and that's what you see here in our answers. Or we can think of this as A, and then what ends up happening is this, our answer becomes 2A. So how long will it take for our money to double? When you do this, you divide, you're left with just 2 equals 1.02 to the x. Now how do you solve for this? Well, you have to log both sides. And then when we log both sides, we end up getting log of 2 equals log of 1.02 to the x. Oops, excuse me, not to the x. To the x power. And then we can use the power property to bring this to the front. We get log of 2 equals x log 1.02. And we can divide each side by log 1.02. Log of 1.02. So cancel. And then our answer, the answer to this is x equals about 35 years. You end up solving the same for the others, and you start noticing a pattern. You can look at this 10, you get log base 2 of log 1.10 to the x. Same thing, bring it to the front, which will end up being x equals log base 2 over log 1.10. You get about 7.3 years. The whole idea here is the rule of 70 is if you have a 10% rate, you get about 7 years for it to double. 2% rate, 35 years. So you take the interest rate and multiply it by the number of years, and you end up getting 70. It'll usually come out to around 70.